Welcome to the deep dive. Today we're going after a really big question, one that a lot of you have asked about.
Huge one.
How does the deepest level of our biology, brain chemistry, actually connect to the highest thing we do, language?
It's a fascinating line to trace.
It really is. So our mission for this deep dive is to try and synthesize two pretty complex fields.
They sound intimidating for sure.
Yeah, we've got systemic functional linguistics on one side and then the core neurochemistry of language on the other, specifically glutamate and GABA.
The excitation and the inhibition.
Exactly. We want to stop talking about ADHD as just, a checklist of behaviors and actually find its linguistic fingerprint, something objective.
Something measurable that points back to that chemical foundation.
Okay, let's unpack this. We're moving from molecules to meaning, tracing how a chemical foundation impacts how you tell a story.
And that framing is perfect because right now, we really do have a diagnostic crisis.
In what way?
Well, for neurodevelopmental disorders, our clinical methods are just so subjective. We're leaning really heavily on rating scales or interviews like the KV-DOs.
And those, they completely depend on memory, right?
Completely.
Hmm.
They're so vulnerable to recall bias. A parent might not accurately remember behaviors from years ago, or a teenager only remembers the fight they had last week.
Sure.
And even more critical is the interviewer effect.
Okay. What's
You
that?
take someone with executive dysfunction, put them in a quiet, structured, totally new clinical office, and their brain goes into overdrive trying to focus.
So they can mask their typical behavior, for a little while at least.
Exactly. The system looks regulated for that 1 hour, even when it's usually chaotic.
So we need a signal that can't be masked. The idea here is that the dysfunction in ADHD is so fundamental that it just, leaks out? It leaks into how we talk?
It leaks. That's the perfect word. If the main problems are with inhibition, planning, working memory, those failures have to show up in the very structure of our language. We just needed a framework that was smart enough to see them.
And that framework is systemic functional linguistics.
That's the one.
So SFL. This is what helps us actually see that fingerprint. When I think of grammar, I think of, my high school English teacher telling me not to split infinitives.
Right. All those prescriptive rules, SFL is. It's so much richer than that. It sees language as a resource, a tool we use to get things done.
So it's not asking, is this sentence correct?
No, it's asking, is this sentence effective for the meaning you're trying to make? And it breaks all communication down into 3 metafunctions.
And it's the failure across all 3 that points to ADHD.
That's the signal.
Okay, let's start with the first one, the ideational metafunction.
Yeah, ideational. This is all about representing reality. It's the content, the who, what, where. It asks, did you build a clear picture of the world for the person you're talking to?
And when someone's executive function is struggling, what does that sound like?
It sounds like a brain working way too hard. You hear sequencing errors, so the story is all jumbled up, not chronological. And, more importantly, you hear a lot of empty speech.
Empty speech. That's a proxy for working memory failure, right?
It is. The brain can't access specific rich words, so it just grabs for generic placeholders.
Give me an example. What would I actually hear?
So instead of hearing, my sister's friend Sarah dropped the red bike she bought last week, you hear
Something like, the girl, she did the thing with the stuff.
exactly that, a total lack of specific people and processes. And you'll hear a lot of uncertainty markers, too. I don't know, maybe, I guess. The brain just can't hold onto the specific words while it's also trying to organize the story.
Wow. So that's the content failing. What's the second metafunction?
That would be the textual metafunction.
And that's about flow and structure.
Exactly. It's all about organization. It's what gives a narrative texture, that quality that makes it all hang together and make sense. And honestly, this is the clearest window into executive failure.
This is where we get that classic zigzag narrative, isn't it?
It is. The speaker can't maintain the theme, which is the starting point of their message. They just keep drifting off topic. We call it theme drift.
So if I ask what you did yesterday,
Instead of a straight answer, you get, well, I got up late, but that reminds me, the show I watched was really good and I need to buy milk anyway, so then I went to work.
it's just structurally incoherent. It puts all the work on the listener to try and figure out what's going on.
The planning mechanism has failed. Simple as that.
Okay, so that brings us to the third one, the interpersonal metafunction. This must be the social side of things.
It is. It's about how we use language to manage our relationships, show attitude, negotiate. And the failure here shows up as pretty obvious pragmatic violations.
You mean breaking the unspoken rules of conversation?
Yes, like violating Grice's maxims.
For instance, giving way too much information or interrupting.
Both. Violating the maxim of quantity, that's the hypertalkativeness, or the maxim of relation, saying something totally irrelevant. These are the audible signs of an inhibition deficit.
The person just can't regulate that impulse to speak.
Right. It leads to blurting things out, interrupting, or sometimes just stalling with filler words while their brain scrambles to catch up.
So we have this really clear three-part linguistic blueprint of failure. But that's not enough. We have to go deeper. If language is broken in these three specific ways, what is going on chemically?
And now we shift to the EI balance, the excitation-inhibition balance. This is, the brain's basic operating system for any kind of rapid processing.
And it all boils down to two main chemicals.
L-glutamate and GABA.
I love the analogy for this. Remind us.
Glutamate is the brain's gas pedal. It's the primary excitatory neurotransmitter. It drives signals forward.
In GABA.
GABA is the brakes, or maybe a better word is the sculptor. You need both working in perfect sync for language to work at all.
Let's stick with glutamate for a second. It's not just about speed, is it? It's about learning itself.
That's right. Glutamate is what gives us the raw speed to process a constant stream of sound, decode phones, grab words from memory. It works through fast AMBA receptors, and then the really critical ones, the NMDA receptors.
Ah, the NMDA receptors, the biological gateways for learning.
They're what we call coincidence detectors. They only open up and create a pathway if two things happen at once. Glutamate has to be there, and the cell receiving the signal has to already be active.
And that's the key to learning.
It's the molecular basis for long-term potentiation, or LTP. That's the physical process of strengthening a synapse. It's literally paving a neural highway when you learn a new word or a new idea.
And the source is really stressed how expensive this process is.
Incredibly expensive, metabolically speaking. To do something hard like hold information in your working memory, you need this huge, continuous supply of energy, glucose, and oxygen to fuel that glutamatergic system.
And if you can't sustain that energy supply?
The system crashes. And that's when you get those cognitive gaps, the empty speech we were talking about.
So glutamate drives everything forward. But without GABA, that system is just a runaway train.
It's pure chaos. GABA is the counterweight. Its whole job is to provide temporal precision.
Temporal precision? What do you mean?
Think about how we can tell the difference between the sound B and P. It's a difference of just a few milliseconds in timing.
Okay.
GABAergic interneurons create that timing. They enforce a little refractory period, basically hitting reset on the neurons instantly. It's a mechanism called temporal segmentation.
So GABA is carving up the continuous stream of sound and carving up our thoughts so we can process them one by one.
It is the sculptor of time. If you lose GABA, you lose your signal-to-noise ratio. Everything just becomes a blur of runaway excitation. You need that break to make sense of the world.
Hold on. I remember something really surprising in the sources about this EI ratio and expertise.
Right.
If GABA is the brakes, you'd think that more control would mean more GABA. But the research points the other way.
It's totally counterintuitive, but that's where the system gets really efficient. In studies of true experts, people who are incredibly fast and good at a task, they've found that lower GABA levels can actually predict faster performance.
How is that possible? Fewer brakes makes you go faster. That sounds like a paradox.
It's all about neural efficiency. When you're first learning something, you need a ton of GABA inhibition to police the signal and stop errors.
Yeah.
But once that pathway is fully paved, once it's automatic, the brain doesn't need as much inhibitory drag to keep it on track.
The chemical profile actually changes with experience.
It evolves. And the research suggests that in ADHD, that EI ratio might be dysfunctional from the start or never makes that efficient shift, so the brain is always spending way too much energy just trying to maintain control.
Okay, this is the heart of our deep dive. We have the linguistic failure from SFL, we have the chemical engine, the EI balance. Now we have to connect them.
And we do that using the dual stream model of language,
Which gives us a map in the brain.
a neuroanatomical map. There's the dorsal stream, which is the how pathway. It handles structure, syntax, the motor parts of speech, the sequencing.
And the other one?
The ventral stream, that's the what pathway. It handles meaning, semantics, understanding.
So we can map the SFL failures right onto these streams.
We can. The dorsal stream, the how, corresponds pretty directly to that SFL textual meta function, the structure and cohesion.
And the ventral stream, the what, maps to the ideational and interpersonal ones, the content and the social rules.
Exactly.
Okay, let's do it. Let's start with that textual failure, the narrative fragmentation, the zigzag story, a structural failure in the how pathway. What's the chemical cause?
That structural pathway, the dorsal stream, it lives and dies by precise GABAergic timing. To plan a coherent story, you have to complete one thought and then successfully transition to the next in order.
And that requires precise timing, segmentation.
It does. And if the GABA brakes are weak or the timing is off in that pathway,
The system just can't reset itself. It can't segment the stream of thought.
the whole temporal order collapses. Instead of thinking A, then B, then C, the thoughts just blur and jump around because the GABA system can't enforce that tiny pause between them.
And the result is the fragmented narrative we hear.
The language is literally losing its timing because the brain is.
That is such a powerful link. Structural failure in language from a chemical timing failure. Okay, what about the other stream? The content and social rule failures. The ideational gaps and interpersonal violations.
So those functions, attention, working memory, inhibition, they live in the really demanding frontal executive networks.
The brain's CEO.
Right. And those networks need a constant high-energy blast of glutamate to keep information active. But to avoid distraction, they also need constant inhibition to suppress all the irrelevant stuff.
So we're right back to that EI balance being out of whack in the brain's highest control centers.
Precisely. If inhibition fails there, if the brakes in the prefrontal cortex are ineffective, you immediately get the pragmatic violations.
The blurting, the interrupting, the inability to stop the impulse to speak.
Yep. Violating Grice's maxims. And the working memory gaps, the empty speech, that goes back to the metabolic costs.
The cost of glutamate.
It's exhausting for the brain to sustain that high-load transmission. When the EI balance is off, the system fatigues. It just runs out of gas. And that's when it fails to retrieve specific words. You get all the placeholders and uncertainty.
So the language of ADHD is really just the sound of a brain that's struggling to manage its own chemical and energy resources,
That is the synthesis.
which moves us from theory into something really practical. The Zhu et al. Study actually built a tool to test this.
They did. This is where it gets really interesting.
They showed this whole theory is robust enough that a computer can detect it. They built this grand ensemble system to basically simulate a psychiatrist.
Yes, they operationalized the whole thing. They took the analytical ideas from SFL and mapped them onto powerful machine learning models to create an objective tool that just analyzes a transcript.
Yeah.
No subjective recall needed.
So how did they break it down? It sounds like they needed 3 different kinds of AI to spot the 3 different kinds of failure.
That's a great way to put it. It was like a panel of 3 expert consultants.
Okay, who was the first one?
The first was Lame 3, a large language model. It acted as the reasoner, the social judge.
So it was targeting the interpersonal metafunction, the pragmatics.
Exactly. They gave it a psychiatrist persona prompt, fed it criteria from the DSM-5, and had it analyze the transcript for social breakdowns. Was the speaker being evasive? Were they hyper-talkative? It judged the overall social interaction.
So Lame 3 looked for failed inhibition. Who was checking the narrative flow?
That was Roberta, the contextualizer. It targeted the textual metafunction, the fragmentation. Roberta is really good at spotting long-range connections in text.
So if a sentence didn't logically follow the one before it, or the topic suddenly jumped,
Roberta would flag that as a break in semantic continuity, a failure of the narrative texture.
and the third consultant was the anchor, looking for the most basic signs of cognitive load.
That was a support vector machine, or SVM. It was more of a statistical counter. It targeted the ideational metafunction, the content gaps. The SVM were just trained to count things like filler words, like uncertainty markers, I guess, maybe.
The exact lexical signs of working memory failure.
Very same.
And when they combined these 3 models, letting them all vote on the diagnosis, the results were pretty amazing.
Highly effective. It hit a really high diagnostic accuracy. It basically proved that these linguistic signals aren't just noise. They are quantifiable evidence of a specific neurochemical imbalance.
Okay, this has been an incredible journey. If we have to summarize the one key takeaway,
It's that the fragmented stories, the empty speech, the social missteps we see in ADHD aren't just random behaviors.
they are the measurable external signs of a compromised glutamatergic GABAergic balance, a broken EI ratio in the brain's language and executive centers.
And that really leads to a huge final thought. There's this idea gaining traction in research called the iceberg phenomenon.
The iceberg phenomenon.
Yeah. You have all these seemingly different conditions, ADHD, borderline personality disorder, even PTSD, that all share these overlapping surface symptoms.
Impulsivity, attention problems, emotional dysregulation.
Right. They look different on top, but the theory is that underneath they might be drawing from the same submerged, shared brain processes.
The same fundamental chemical imbalance.
Exactly. If we accept that all these issues, language problems, attention deficits, impulsivity, stem from a fundamental failure in the chemical EI balance, it forces us to rethink what a diagnosis even is.
So here's the final thought for you to chew on.
Does this mean that what we call monolithic diagnoses, like ADHD or dyslexia, might actually be a whole spectrum of different chemical subtypes?
So one person's ADHD might be too much gas, too much glutamate-driven excitability.
And another person's might be not enough breaks, a GABA-driven timing failure. Does the future of treatment lie not in treating the label on the box, but in precisely correcting that person's unique chemical ratio?